Let's talk about section 2.2, which is about fitting lines to data points, where we kind of look more at modeling linear functions here. Now, as we look at this information, what we're going to do is we are going to find exact linear models for data, determine if the set of data can be modeled exactly, or is it going to have to be approximately. We're going to create scatter plots for sets of data, find approximate linear models for that data, and we're going to visually determine if it's a good fit for the data. And then we're going to look at some of them, solving some problems that have these models. So what is the exact difference between a approximation and exact? Well, the first difference that you might find is when we talk about the word exact, is that the difference between the outputs are constant and uniform, meaning basically that rate of change going between your first set, between the two different values that you might have, and the second set, the first two different values you have there, are exactly the same every single time. Okay, when you have something like that, that's going to be an exact model. Now, if the first difference is almost constant, but then we go to the next two set of data points and it's slightly different, and then as we continue to go through the differences between those sets of data, going from like 1 to 2, 2 to 3, 3 to 4 on my data values itself, it's close, but it's not exactly the same every time between the difference of the numbers, then that's going to be what we would need an approximate fit. So let's take a look at that. So let's look at the following table, and we're going to be given the annual retirement payment to a 62-year-old retiree with 21 or more years of service at Clarence State University as a function of a number of years of service. And the first difference of the outputs, let's look at that. So we have 21 years of service that we're looking at here. And as we start here, normally with our years of service, this is going to be our first set, which is normally what we would refer to as the domain. Okay. If you're using variables, we would normally call this one the X variable, right? So in our case here, we see that going from 21 to 22 to 23 to 24 to 25, that basically our difference is that it basically adds one every single time, which is exactly what we want to see. But we now have to look at our second set of data, which our second set of data is going to be the retirement payment. Now, normally we refer to this one as our range. And again, I would call this, if we're talking about in terms of variables, that Y variable. Okay. And if I look at the difference between my first data point and my second data point in the second set here, I got 1950. And then when I go from the second data point to the third data point, I got 1950 is the difference. And I notice that again, as I go up every single time, it's a difference of 1,950. So noticing here that we have the exact same difference every single time as I go between my data points on not just my Y value difference, but my X value difference. And that right there tells me that we're kind of looking at more of a set. Now, this set is going to be an exact set of data, which means I can do linears, okay? And because it is exactly the same thing every single time, I can write an exact linear equation to make this work. Now, again, in order to make that exact linear equation, what we want to do is remind ourselves that we learned about a formula that is called the point slope form. So as long as I know the slope, which is again that rate of change, which is why we're checking this, and any point on the graph, I can take that, plug it in, and notice that it will always work and predict for every single year. So if I chose X equals 21, I'm going to get the right answer. If I chose X equals 22, I'm going to get the right answer. If I chose X equals 23, it's always going to give me back that retirement payment that is exactly what I have in my chart. And again, this would be if I'm looking for something that is exact. So what am I looking for again? Well, the first thing I'm going to look for as I do my exact is that I'm looking for the differences. So we're looking that this difference here is exactly the same, and this difference here is exactly the same. Now, if they're not exactly the same, double check to make sure that this top part here If it's not going up by 1 every single year, maybe it went up by 2, make sure that this number down here doesn't look like it's double what it was, okay? So it should have a slope that is pretty much the same between all the different points. Okay, now we're going to note that those values that we put on a table are basically what we call a discrete function. Now that is a function with a finite number of inputs, with each input representing the number of years of service. So now, although only points with integer inputs represent the annual retirement payments, we can use a model that is a continuous function. So in our case here, y equals 1950x, that's what we solved it out for. We know that it's only going to hit the 5 points that we were looking at, but when we draw it on the paper, we're going to draw it without actually lifting our pencil or pen. And so it's going to look like it's actually continuous. So it would actually work for things like the year 2.5. And that's not necessarily to say that that's not a bad function. It's just to say that this models it, but we do have to remind ourselves that our inputs are basically those exact numbers, meaning that it's discrete, okay? So this is what it would look like and the difference between the way we might display the data. So in our first case here, I would put my data in these beautiful points, which this is what we call a scatter plot, okay? So this is our scatter plot here, okay? And our scatter plot is basically, you plot the points. Now it can be approximately fitted by the line. So the line that we created, that y equals 1950x, that is what we would call our best fit line. Now we know, because we've already done all the math, that it's an exact model. But what if I wasn't sure if it was an exact model? What if I didn't take the time and actually find out what that slope was between all the different points? Well, that's what we would call basically that line that fits it, what we would call maybe a best fit line. Okay, so let's try this out. So we're going to take the following table, and it's going to give our projected population in millions of females under the age of 18, and we're going to project for the years between 2020 through 2060. Now, the first thing off the bat that I begin to see here is that I am beginning to notice that there is a difference in the years, and it does look like it goes up by 5 every single time. However, I also notice as I'm looking here that this here looks like it's the same until I get to this point here. So we are going basically +5 every time we go up in the years, but I thought we were going up by +10 until I got to this point right here, which 39.8 did not go up by basically not a +10, but a 0.1. Sorry, that it's not the same. And that's where we kind of have to take our note there, is that it doesn't go up exactly the same every single time. It looked like it got really close. So we were like, okay, this is going up by 1 every single time, 1, 1, 1, 1. And then we end up with a up by 0.6, which is not the same as 1, which means this is not going to be one that I can use that y minus y sub 1 equals m times x minus x sub 1. So what do I do in cases like this? Well, for these, the first thing I want to do is I actually want to let the calculator do most of the math, okay? So what we're going to do starting off is we're going to realign the data with the x values of each point representing the number of years after 2000. Now, how did I pick the year 2000? Well, that's normally going to be in the problem. So read in your problem, it's going to normally show a beautiful table like this, and then it's going to say x is the number of years since blah, blah, blah. So that's going to be kind of your 0 year. And what we're going to do is basically realign there. Okay, so we're going to take this first year, 2020, and it's no longer going to become 2020. It's just going to be 20. And we're going to do the same thing here. And this is going to become 25, then 30, 35, 40. We don't touch these over here. We leave those alone because this is basically my x value. This is my y value. We don't touch the y values. The x values is the only one we're tweaking because that's the only one that said we're going to realign that one alone. Okay. And then here we have 45, then we've got 50, 55, and then 60. Okay. So as you guys can see there, we've realigned it. Now, why was it really important to do the realigning? Well, what we are going to do is we're going to answer the following data. And this is why I do the realignment, because normally in part A of the problem, it's going to say, draw a scatter plot of the data where X value of each point represents the number of years after 2000. Okay. So again, that is that keyword that I'm going to be looking for, and it's going to show up every single time. The number of years after 2000. Okay. Now, Y is going to represent the population of females under the age of 18 in millions. Okay. After we've done this scatter plot, then we're going to do the graph, and then we're going to find a line through 2 of the data points and see if it actually is going to make a good fit. So to start us off, let's do our scatter plot there. And to bring up our beautiful scatter plot, what we want to remind ourselves of, let's bring that up there. There we go. We're going to need the calculator. Okay, so remind yourself on your calculator here. So I'm going to start with a nice clear history there. Step 1, when you're doing this calculator, basically anytime that we're doing any type of regression or best fit line, we're going to go to this beautiful stat button. Okay, again, remember, we're kind of creating what we call a scatter plot. So stat. Okay, and we're going to go with number 1. Now you can hit the number 1 or you can hit enter because number 1 is highlighted over here. So either way will work there. And then we're going to enter in that data. Okay, now here's where the fun bit is. You're going to need the data up. So let's do the data. Take a second, pause the video if you need to. Okay, and input your data so that way you can kind of help with that, putting it in and learning how to put it in. Okay, so we've gotten all our stuff in there, and I do want to take a second as you guys are typing all this in, double check before you do too much. One of the things a lot of people don't remind themselves of is basically you kind of need to just be super positive on that everything is correct in there. So what I highly recommend is that you go back and kind of arrow your way up through the different things. Okay. If you have a mistake, just literally go to the place that you have the mistake and edit by just typing in whatever it should be and just hit enter to execute. You will notice that on like 41 and 42, it does say 41.0 and 42.0 in the table. But guys, remember, do we really put 5.00 every single time we say $5? No, we don't say 5.00 every time. We just say 5. And that's kind of where those point zeros disappear. So if you have something like that, don't let that bother you if they happen to disappear. Okay, so we've got that in there. What we're going to do now is we're going to continue on with this whole draw that scatter plot. Okay. Now, we start off by realigning, and that's the very first thing that you have to do. Once you realign, so instead of putting in 2020, we put in 20, okay? We kind of want to now plot all the points. Now, you can do this by hand, but we have this calculator for a reason, and basically, we're going to let the calculator draw that graph for us. So how we're going to do that is we're going to start by hitting second y equals. Okay, now second y equals will take you to your stat plot. With your stat plot there, you want to hit, just make sure number 1 is highlighted and hit enter. And then we're going to hit enter to turn it on. Now remember, we will have to turn these off at some point. So remember, how to turn them on and off is by going to the stat plot menu and turning on and off. Okay, I'll show you a little trick a little bit later on how to do that in a little bit quicker of a format. Now, there's a lot of these different types of graphs here. We're just going to do the one that's got the little dots. It should be automatically selected, and then it should have list 1 and list 2 already marked in there. As long as you don't delete a list, all of this should not change. If you've got a color, go ahead and change the color if you want. It's up to you. It's not going to really matter what color you make it. Okay. I recommend the really big box for your markers just because if you've got really bad eyesight, it really does help to have the bigger ones. Plus, also when you start doing other things with it, like seeing if a line is a best fit line, You want to be able to see those and not let them blend in. So it's easier if they're the boxes. Okay. Once you have them in there, just go ahead and hit Y equals. Now you'll notice I've got a lot of stuff in my Y equals. So what I'm going to do is I'm just going to clear out anything I have in there. Okay. We don't want anything to be showing up here. Okay. So it should just be plain old Y equals. If there is stuff in there, go ahead and clear it out. Eventually we might put something in here, but we want to kind of keep it open. So Y equals is clear. Our stat plot, so second Y equals, it's on. Okay, and again, list 1 and list 2 selected, and we've got it set there. Now what I want you to do is hit the zoom button. And since we're doing some stat stuff, we're going to hit number 9. This will allow the calculator to set the best viewing window for you. Okay, so instead of you having to play the whole guessing game of like what video window is going to look best with this, like, nah, just let the calculator do it for you. And there you have it. Looks very similar to the one that they drew for us, okay? A little bit different is because I have a slightly different viewing window range, but we can see that the way it looks. Now, as we see how it looks there, we can kind of see that it doesn't look like it's a perfectly straight line. It's got a little bit of a wiggle to it. So previously we had those other ones, they lined up absolutely perfectly. And these ones we can see like, it's not going to be perfect. And again, we established that earlier on that my list 1 all changes by 5, but my list 2, I got 1, 1, 1, and then a 0.6. So it doesn't always change at the same rate. So let's determine whether this is actually going to be a good fit. So I made a guess and I'm going to say it's Y equals 0.1x plus 36. Let's see if that is actually a good fit for our data. Okay, so I'm going to pull up my graphing calculator here and I'm going to plug in my Y equals. Now remember, we had it was 0.1x. Now remember, for x, you're just going to use that x t theta n, and then it's plus 36 there. Okay. And again, this is exactly what they told me to plug in. So I'm not making anything magical or anything like that. I'm literally going to plug that in, Y equals. Now, we don't need to do anything else because we've already got the graph exactly where we want it. We want to see, does this line that they've told us, does it actually work? And I'm going to hit graph. Now, as I take a look at that, I'm beginning to notice that my line doesn't really hit many of the points. I see that it hits a few, like maybe 1, possibly 2, but it's not really at the same rate of where it needs to go. Okay, so is it really a good fit? Not really. Okay, it does feel like it is kind of modeling it a little bit, but it's not the best fit that it could possibly be. So what could I do to possibly make it be a better fit? Well, there's a few different things. We could try 2 different points and create a line with 2 different points. Okay, so let's find a line through 2 of the points that is maybe a good visual fit and use 2 points to write this equation of a line. Now remember, if we're actually going to write an equation of a line, we're going to use this option here. So this means I'm going to have to pull up my data and pick 2 of those points. Now, as I pick 2 of those points, I kind of want to pick some so it would maybe look like it maybe goes through those. So maybe take the 2 endpoints, that might work. Any 2 points will kind of make it maybe possibly look better. Okay. Okay, so we're going to do that math real quick here. So I'm going to choose that 25 and 38.2, and I'm going to choose 60 and 43.6. So you notice I'm actually choosing not the very first point, but the second point and the last point. Does it really matter? And it fears that it's a little bit better of a fit when I choose that one. Okay, now if I did the equation itself, it would be first I have those 2 points I chose, find my slope, and then plug it into that y minus y sub 1 equals m times x minus 1, and I got this graph here, which originally, remind yourselves what we actually graphed was this, and see how different that 0.1 versus 0.154 actually makes a bit of a difference. Also, starting at 36 here is my initial, and over here I'm starting at 34.36. So it does make a slight difference as I take a peek at these. Now, is it the best fit? Well, not really. Okay. but we can compare it to what we have. It is a lot better of a fit from the one that we had in part B. So how do we actually determine the best fit line for all these data points? Okay, so this has actually got an entire thing all to itself, and it's called linear regression. Okay, so you might want to make note to yourself, if I use the words linear model, I might say linear regression, or I might even ask for the best fit line. Okay, if I use any of these three combinations of words there, what we're going to be is basically, this is actually got an entire procedure. Now, are we going to do this all by hand? Heck no. Okay. Before the age of calculators, this was done all by hand. You guys have a calculator, use it. Okay. Excel will also do this as well, but we're going to use the calculator to help us out here. So basically the procedure itself, it's called the best fit line, and it basically takes the sum of the squares of all the vertical distance from the data points and finds a line that is basically a minimum that distance from all of them. So there's a lot of steps to this. So if you want to pause the video and take a look at the steps, that's perfectly fine. Basically, step one is you got to put the data in the calculator. Step two is you want to create a scatter plot. Check to see if it is linear or not. We'll learn about things that are not linear later, but if it doesn't look anywhere linear, you're going to see that it's not going to work very well. Step three is you're going to basically obtain the linear equation from the calculator, which has got a whole step process in itself. Step four is you're going to graph the linear function. We are going to look at unrounded and rounded, so I'll show you the two differences between those, okay? And then step five is report the function, where you might have to maybe make adjustments for rounding or anything like that, depending on what we have. So let's try this out. And again, here, we're going to look at a lovely problem. So we'll look at the total US population for selected years beginning in 1960 and projected to 2050. And it's shown below in our beautiful table here. Again, we've got years and populations. And the first thing I notice is I see 1960. So I'm going to be like, wait a second. So looking through the rest of the problem, I'm going to look for some really key question kind of data thing that needs to help me out here. And I see it straight away. It's normally in that very first part there. Align the data to represent the number of years after 1960. Okay, so that right away tells me I am not going to plug in 1960. Okay, again, that's almost always going to be somewhere in the problem itself. So we are going to make that kind of adjustment there. And we're going to change this 1960 to be our 0 year, because that's what they said was basically the number of years since 1960. So 1960 basically is x equals 0. Okay, that means this one here is going to be 5. Here we have 10, then we have 15, and so on. Now, I do want to point out, you want to be very, very cautious. Why am I saying being very, very cautious? Is don't always assume that it goes up by 5 every time. Okay, this one here does happen to go up by 5 quite quickly here. However, the moment I hit over here, after 1995, it becomes 1998. That is not 5 years away. That is 38 instead of 40. So this is why I say don't go in like this habit of like always doing the exact same thing over and over. Really kind of watch what's actually going on when you input your data. Okay, and so we can see here that I am going to have to make a little bit of a change because it does make it slightly different. I also noticed that once we get here to 2025, that is definitely not even a 5-year jump after that at all. And then we've got 2050, which again is not even that 5 jump at all either. So be very, very cautious with that. Now, with that, let's talk about how to put this in the calculator and make sure that we are typing everything in the calculator correctly. So I've already got stuff in there. So let's just go to Stat, and we're going to go to Edit. Now, you guys will notice that I actually have stuff already in there from the last time I've done this, which is perfectly fine. It does happen, okay? But what I want to do is I do want to make sure that I start with a clean list. I don't want to actually take the list that I have here and edit. I want to kind of start completely fresh. So what I'm going to do is I'm going to hit this up arrow here, and you'll notice that list 2 is highlighted, and I'm always going to hit clear. Whatever you do, please, for the love of everything, do not hit the DEL. DEL stands for delete. We don't want to delete the list. We want to clear the list, okay? The reason why I say is you don't want to delete the list. If you hit delete right now and then hit enter, it literally will delete that list out, which means when I go back up here and go to that stat plot, there's no longer a list 1. It's now list 2, which creates a huge issue, and there's a lot of things that you have to tweak later on. So what I strongly encourage people to do is always clear the list, okay? And we're just going to clear list 1 and list 2, okay? And I just kind of try to always continuously do list 1 and list 2, and I always clear, never, ever, ever delete, okay? Now, once you get all that stuff in there, you're literally going to start your process of typing in your numbers. Again, as you type them in, you should be kind of getting that nice, lovely format there. Now, I'm kind of stopping at 35 for a second because I want to jump here and show you a little trick. So we've got 35 and then 38, but you notice it's different, but maybe you don't know what the next number needs to be. So say you're going to do the 35, you hit enter, and then you get to the next number and you're like, I don't know how many years away that is. So let's type in the year 1998, and then we're just going to say subtract out my 0 year there. And when I do that, so I've literally done 1998, which is the year I have currently right here. And then I subtract out the 0 year that they told me, okay, I can see that it actually gave me what it needed to be, okay? So that's really, really helpful there. So again, basically you can just type in the year, but you have to remind yourself that you have to say subtract out your 0 year every single time. It does become a little continuous in that it's a little tedious, I would say, that you have to always hit the subtraction to get that in there. But if you're struggling with that whole how to add, subtract, multiply, or divide to get the numbers or anything like that, this would be a good option. So like for 2025, that's so different. And it's like, I don't even know, like instead of me actually taking the time and doing the subtraction in another screen and then coming back to this, I can literally just type that in there and be like, okay, the answer was basically 65. And you can do the same thing every single time, which is really, really nice and helpful there. And we can see that for that 1950, it is basically 90 years away from our 1960 year. Okay, so go ahead and take a second and pause this if you need to type in all that data. Okay, take your time, pause, and make sure that you are feeling very, very comfortable with typing all of this in. It's very important that you, as the student, get the actual experience of typing this in. I know you guys are doing stuff in your homework, but remind yourselves that you always want to kind of pause, take the time, and really make sure that you know what you're typing in correctly. Okay, so we have just figured out how to put it all in your calculator, right? Now, I do want to kind of go over one thing because I do know some people might freak out a little bit on this one. And I don't want you guys to freak out because it is something very common. So as we take a peek at this, let's look at the calculator. I'm going to make my screen really big on that calculator there. So if you'll notice the first thing up here, as you look at the list 2, which is those Y values that we're talking about, if you look at the number here, it's not going to show the whole number, but if you highlight it, it will. So as I go down to like the second one, it was 194.303. And again, I can only show so much in the table itself. So what you have to do, especially with this one, is before you jump out of this screen, you always want to just go back and quickly double check that everything is correct. Again, So we can see that, especially on that last one there, it says 408.7. That's not what I typed in. I typed in 408.695. And what it is it can only show so much of it. So it does kind of automatically round up. But when I highlight it, this is what it says I've actually typed in. And that's very important to kind of watch for that. Okay, so take a second, double check everything. And then once you've got that, you can kind of be like, okay, I'm good. Once you've done part A, we're going to create our scatter plot now. Okay, so let's go with our scatter plot. Now, remember how we did that was basically we went to second y equals. Now, if it's already on, this is kind of nice, but remember, this is basically making sure that it's on. Then we go into y equals itself. Now I have the old stuff in there, so I just want to hit clear. And then I'm going to always, whatever you do, because if you hit graph right now, you're not going to see anything. So you always want to hit zoom and then number 9, because every time I put in new data, I want to make sure that the line, it does show up. Okay. And we can see with our beautiful new data, it does look a little kind of linear. Even with these like two massive like outward numbers, it's a little bit of a straight line. It does have a bit of a curve, so it's not going to be perfect. Okay. So we're going to create that linear equation now. So let's do part B. Okay. So for part B, we're going to create the linear equation that is the best fit line. Okay. And then once we do that, we're going to graph them on the same thing. And we're going to see how well it kind of lines up. So step 1, stat, edit, put all your stuff in. Okay. Step 2 is going to be once all this data is in and you've looked at the graph, so you've done all that scatter plot. So step 1, you've done the scatter plot. Step 2 is I need you to go back to the stat button and I need you to arrow over to calculate. Okay. Now we are going to become uber familiar with this lovely menu. Okay. So this is the stat calculate menu. Again, I hit stat to get to it, arrowed over to calc, which again is calculate. And basically we're going to look at number 4 here, which is ln reg ax plus b. Now don't forget there is one down here that says ln reg a plus bx. They are technically the same thing. It's just a slightly different formula. We prefer number 4. Okay. So you can scroll down and hit enter, or you can actually just hit the number 4 and that will work. Now, again, this is one of those things that please make sure that when you do this, that you have not deleted a list. This is why it's so important not to delete the list. Now, I also am going to put a little pause right here for the second of saying, for those of y'all that have a TI-83, hang on one moment and I'll get to you guys. This is what my TI-84s will see. So they will see this kind of pop-up menu that says list 1, list 2. And then basically don't put anything in for the frequency list. And then the store reg equate, we're going to leave that blank for a second, and then we're going to click calculate. Okay. And then you should come up with this beautiful thing that says y equals ax plus b, and then it should have an a and a b. For my TI-83ers, so let's talk about you guys. You don't have that beautiful pop-up menu. What you will have is it will literally say this right here, ln reg ax plus b. So when you select number 4, it shows this. Now we have to tell the calculator. So this is a slight difference between the 83s and the 84s. For those of y'all that have the 83, you have to tell it what list to use. So what you're going to do is you're going to hit second 1, because second 1 is going to give me list 1, comma, second 2. And then hit enter, and you'll get the same thing that everybody else is back with seeing. So 83 or 84, it's just a slight different. 84s have a nice little, basically like app window, I guess you would call it. It's got a little kind of menu to kind of fill out, whereas the 83 does not have that menu for you to fill out. But you should get this beautiful equation here. Now, as we take a look at that equation, what that is doing is that equation itself has basically given what we need. Now we can round it and we can use the unrounded version. So what we want to do is we're going to make note of that rounded and unrounded version. So the unrounded version has a lot of decimals, and we don't want to really make any mistakes with rounding anything so too early, so we don't really know what the difference is there. So what we're going to do is we're going to go back to that stat, calculate, and number 4 there. And do you remember when I said that store reg equa, we were going to kind of pass over it for a second? Okay, to put the unrounded version, so if it doesn't say to round, we always do the unrounded. To put the unrounded version here, what we're going to do is you are going to hit alpha F4. Now that would be alpha trace if you don't see where it says F4 here. This should be a pop-up menu and it's the first one there, Y1. We want to put that into Y1 and then you're going to click calculate. Now, again, for my TA83s, I know you're like, wait, how do I do that? Okay, so what you're going to do is you're going to do that same thing that we did earlier. And then you're going to say second 1, comma, second 2 to get list 1 and list 2 in there. And then we're going to say comma, and now we have to put that Y1. Now, I'm very sorry. It is not as easy as just hitting alpha trace. For the TI-83s, what you're going to have to do is you have to basically go and do a little bit more digging. So the easiest way that I have found, if you find an easier way, please let me know, is I hit the vars button. Okay. Arrow over to Y vars, number 1 for function and number 1 for Y1. Okay, one more time, just so in case for my TI-83ers. So you've already done that whole list 1, list 2, and we're going to say comma, and then we're going to go vars, arrow over to the Y vars, number 1 and number 1. Okay, and then when you hit enter again, you'll get the same thing there. And what's really cool, guys, if you guys just hit Y equals right now, notice what it has done. It has literally put the entire function in. Yay! Okay, so the function is fully in. It's super nice and awesome. Okay, and it's the unrounded version. Now, while we're at this here, we're just going to go ahead and put the rounded version in as well. So I want you guys to see the slight difference between the two. Okay, so I'm going to put the unrounded in blue and red is going to be my rounded. So that 2.607x plus 177.195. Okay. Now, again, this has basically been rounded to 3 decimal places. Again, read every single problem. There's a couple of them that like to say to round 3 decimal places. Some of them will say round 4 decimal places. And some of them will say round to a significant digit. So those you kind of have to be on the lookout for. Okay, let me make that screen way bigger again. So we've got it in there and I'm going to hit the graph button. And again, as you guys take a peek at this here, remember that our blue line there, so the blue line that we see is that nice, lovely, unrounded version, okay? And then as we take a peek at that red line there, the red line ends up looking almost identical. So it's really, really kind of hard to actually see that because of, oh, I messed up. You guys didn't catch me. There we go. So now when I hit graph, you're going to see the blue line go, and then that red line is almost identically on top of it. So that's why we kind of round with a couple of decimal places on it, because you can really see that it's super close there. Okay. Okay, so we can see what it is in there. And again, we always want to try to do the unrounded version versus the rounded until they tell me to use the rounded. Okay. Now, I'm not going to make you guys do this, but one of the cool things about doing all of this is what if I had realigned the data and said, what if 1960 wasn't my 0 year, but 1950 was my 0 year? How would that differ? So that would basically change all those X values, correct? And with changing the X values, it does actually change the starting value that we have. So that initial y-intercept value changes, but you'll kind of notice as you look here, I've already done it for us, is that slope did not change. The slope is not what's changing there. It's literally just where we start. So that having that X is the number of years since, and then whatever year that is just basically giving me a little bit more of a reasonable initial starting point for the graphing calculator or Excel or whatever I'm using, okay? So it doesn't actually make that much of a difference. It will still give me the same answers both ways, okay? So even though the X values basically are given that are 10 more than everything, but the answers end up becoming exactly the same, which is super cool and interesting when you get that. Okay. Now, let's talk about the models for a real second. So most models, most of the data that you look at, which the function and applications are derived from end of year totals. So thus the modeling, when we talk about them, follows kind of a convention unless otherwise specified. So what we look for is a point of input access is normally the time. We prefer to do the input of time as my x-axis because we want to see as it changes over time from left to right. So for instance, the point of representing the year 1999 means basically at the end of the year 1999. And you'll notice that this instance in time also represents the beginning of the year 2000. Okay. Now, the other part is the goodness of the fit. Now, the goodness of the fit of the line to set data points can be observed actually on the calculator, but it can also be observed by basically plotting the points along with the best fit line at the same time. Okay. Now, it can be measured in the graphing calculator, and the graphing calculator will spit it back out using what we call a correlation coefficient. Now, the correlation coefficient is a number. We like to call it R, and R happens to be between 1 and -1. And this R represents the measure of strength of a linear relationship that exists between the two variables, whatever they might be. The closer that R is to 1 itself, and preferably we say the absolute value of it, basically tells me how good of a linear regression line we have. So think of that 1 as like it's almost 100% accurate. Okay, now you'll notice that my calculator did not show the R when I did the regression, right? So when I did my stat, my over to calculate and number 4, oops, stat, arrow, over, calculate, number 4, and I did my regression, it didn't give me an R. And that's because most calculators have to be told to make the R show up. So if you want to see the R, so all you have to do is hit mode. And then once you're in the mode button here, you'll go down to where it says stat diagnostic and turn that on. Okay. And once you've turned that on, so stat diagnostics on. So again, just arrow over to where on is blinking and hit enter, and the little black mark that was on off has now been attached to the on word. We just second mode to quit out of that, and we run our regression again. So stat, arrow over to calculate, number 4, and then again, all the way down to calculate, let it calculate out. And you'll notice now, instead of just y equals ax plus b, we now have an r squared and an r. And that r itself there is the correlation coefficient. And we can see here that it's like 0.997. So it's positive, which makes sense when you look at the graph. It's positive because this is a positive slope. And it's 0.99 because if again, it almost hits almost every single point, right? Like this is the only one it doesn't like really hit. Every other one it hits. So it's a really good indicator. The closer that is to like the number 1 itself, the better it can be. And again, it's the absolute value of it. The negative symbol will only tell me if I'm kind of going in a negative direction on my slope. Now, for those of y'all that have the TI-83s, you'll notice that when you hit the mode button, you're not going to see this beautiful stuff here. In order for you to turn on your stat diagnostic, it does require a little bit more work. And to do that, I'm sorry, you're going to have to hit second 0 to go to the catalog. And then you're going to have to scroll until you see the Ds. Okay. And basically where it says diagnostic on, you're going to hit enter. It will bring it to the home screen, and then you hit enter one more time. It should say the word done. And once you've done that, the stat diagnostic should be turned on. Again, this is not automatically turned on a lot of calculators. And for those of y'all that move into the statistics class next, or any type of statistics class later on, you're definitely going to want that diagnostic to be on. Does it really have to be on for this course in particular? No, but it is good, helpful information to kind of begin to see and get used to whether or not this is really something that you want to look at. Okay, again, the closer that number is to 1, the better you're going to basically have for your data itself. Okay, that is basically everything you need for your 2.2. If you've got questions, remind yourselves there that you want to make sure to ask your instructor for more information.